Let's talk more about Ethernet cable. Cat5, Cat5e, Cat6. This is an example of Cat5 or Cat5e. I'm not sure which one was that. So you can see the 4 pairs, twisted copper wires, and each pair is in one type of color. So it's orange, orange, white, green, green, white, blue, blue, white, brown, brown, white, and on one sleeve, in one sleeve together. And all those cables, Cat5, Cat5e, Cat6, will have those wires. The difference will be the way they are twisted, the way the cable is built inside, because those cables, when the number is growing, Cat5 will be the very old type of cable. Cat5 will be more modern. Cat6 will be pretty new cable with much higher parameters. So Cat5 and Cat5e consist of 4 pairs of twisted copper wire, and maximum length of cable between devices is about 100 meters for Cat5, and speeds, it's about 100 meters, but for Cat5 and higher speeds only 37 meters is recommended. So see, Cat5 can handle from 10 to 100 megabits per second at 100 megahertz. So if you're using those smaller speeds, 100 meters is fine, but if you need those speeds, you may want to have shorter distance to reduce the loss of data, crosstalk, and stuff like that. Cat5e, which is enhanced, cable supports up to 1000 megabits, which is 1 gigabit per second. You can connect IP cameras with Cat5 because most of the best cameras, the megabits per second are below 10, but Cat5e is recommended because especially the price between them is difference in the price is negligible. Cat6 is different story, it's more expensive. Cat6 also consists of 4 pairs of twisted copper wire. Cat6 has a bandwidth capacity of 250 MHz and speeds of up to 10 gigabits per second. Maximum length of the cable between devices is 100 meters for 1 gigabit and 30-50 meters for up to 10 gigabits. Cat5 cable has inside a nylon spleen which helps to eliminate crosstalk. It offers lower crosstalk comparing with the Cat5e and higher signal to noise ratio. And again, that's our ready patch cable, Ethernet cable with RJ45. You can see those 1, 2, 3, 4, 5, 6, 8 connectors, yeah? And these are connectors which you can see. Like you can buy a ready cable, but those cables come, let's say, 1, 2, 3, 5 meters maybe. But then if you run a 50 meters cable, you just buy a Cat5, Cat5e in a roll, and you cut it to the size, and then you terminate with the RJ45 on both ends. There are 2 general types of Ethernet cables, crossover and a straight through. Ethernet cable is terminated, as I said already, with RJ45, which has 8 pins for 8 wires, and they can be numbered 1 to 8. In a straight through cable, wire connected to pin 1 on one side is connected to the pin 1 on the other side as well. So, and the same goes for all 8 pins. So that's a straight through. So pin 1 goes to pin 1, pin 2 goes to pin 2, and you use obviously the same color, the same cable. In a crossover cable, wires 1, 2, 3, and 6 are swapped on the other side. Green is swapped with orange. That's a crossover cable. So you can see that on this side there's a pin 1, pin 2, pin 3, pin 4, pin 5, 6, 7, 8. So pin 1 goes to pin 3, and this goes to pin, which is 6, and this one goes here, and this one goes here. So that's why I called crossover. Basically, orange is swapped with green. The blue and brown is the same. That's a crossover. A connection of an IP camera to the switch is with a straight through cable. So cable when pin 1 goes to pin 1, pin 2 to pin 2, and keeping the same color. There are two types of terminations used for straight through cable. One is called T568A and the second is called T568B. And there's tiny difference between them. They basically have again cables brown and green swapped. I mostly use this, but doesn't matter which one you use. You can use this type of termination or this type of termination, as long as you do the same type of termination on both ends of the cable. You cannot have one side of the cable this and then that, because then you get a crossover cable. You must have this type of termination on both ends of the cable, or this type of termination on both ends of the cable. Doesn't matter which color you use. You could create your own termination type. It wouldn't matter really, but obviously it's better to keep the standard. So I'm using this, and most installations I've seen this, but that's in Ireland. In the UK you may be using this, I don't know, hard to say. Never done installation in the UK or US for that matter. So these are types of terminations. So pin 1 goes to, in this type, pin 1 has orange white, pin 2 has orange, pin 3 has white green, pin 4 has blue, pin 5 has white blue, pin 6 has a green, pin 7 has a white brown, and pin 8 has brown. Which pins are actually used? So you have those 8 wires, but in reality they are not all used. So in Cat5 cables, or 5E, you have those 4 pairs, but for speeds between 10 and 100 megabits per second, networks only use 4 wires, 2 pairs. So wire 1 and 2 is used for sending, and wire 3 and 6 is used for receiving. So in termination type T56B, it will be respectively white orange, orange, white green, and green. And if you look there, in this type, these wires are being used for those smaller speeds. Most of the cameras will use the above setup. For higher speeds, like 1000 megabits per second, you will use all 8 wires to achieve that speed. But each pair will still have the same speed, but you double the speed by sending data simultaneously on all those pairs. So instead of 4, you're using 8, and that's why you increase the speed. Obviously, when you're creating your cable, you need tools, and this is a stripper and a crimper. You basically cut your RJ45. You strip the insulation sleeve. You strip the wires, make them proper length. You stick them into the RJ45 in proper order, and you squeeze it with that multiple times. I won't be showing that on the video because, well, there are countless YouTube videos with that, and those people are really good and fast, and they show you. It's all the same. There's no need to waste time for that. You can go to YouTube and find it yourself. That's another thing which you will need for networks: a tester. And it's a basic tester. So, for instance, let's assume that you're creating that 50-meter wire. You strip the cable, put in the plugs, crimped, you terminated the cable. So now, to avoid the confusion, if something will not be working once you get everything set up, you test the cable. So one of them is receiver and one is the sender, and we can have a look on the side of that. See, there's sender, receiver. You just plug your cable there and there, and you set it for test, and we'll start testing wire by wire. So if it shows white, green, on the number 1 you have green, you should get the green there. If you get the green there, you should get green there, and they'll just go through every cable. If it is a straight through cable, you get 1 for 1, 2 for 2, 3 for 2, 4 for 4, and so on. If it's cross over, obviously for certain wires you will get different wires. You will not get number 1 for number, if you look back to the crossover cable. But we are not using crossover cables for cameras, only straight through. So this will tell you if every core is working, if there's a short or a wire is broken, or you just wired them improperly. So it's a good rule to test the cable before connecting. Once you make the cable, terminate the cable, it's already there, just hanging on the one side beside the camera, on the side beside the NVR. Just connect that tester or whatever tester you get, which are cheap. You can get them, plenty of them, on the Amazon, and check if your cable is actually working, because that way, if something is not working, you know already the cable is working. Thank you.